All right, so I'm calling this like technically like an extension of 1.3, but the way this is in the standards is actually like a sneak peek into topic 2.2, which is fine, it doesn't matter. But what we're going to do today is find the equation of a secant line. But before we do that, I want to make sure you remember what a secant line is. So if I had this quadratic equation graphed, and then this was -1, and we'll say this is 3. And you are asked to find the average rate of change on the interval from -1 to 3. What you're asked to find is, whoa, I did not draw that very well. Let me start over. Oh, I almost said a bad word right on a video. Okay, we'll start over. What you're asked to find is the slope of this line. There we go. We'll pretend it's going through 1, 1. That's the secant line. So, how do you find the slope between those 2 points? Like, what do you use? Or how do you find the average rate of change? Say it again. What do you subtract on the top? Yes. All right, so what we're going to do now is we're going to use this formula that everybody already knows. I'm going to try to just erase these little 2's. There we go. And we're going to solve it for this y. So if you were going to solve it for that y, what would you do first? Multiply what's on the denominator. Good. All right, then what would you do? Yes, sorry. So y is going to be equal to y1 plus m times x minus x1. Right? That gives you the equation of that line. All right? So that's what we're going to fill in that blank. So the equation of the secant line, or any line, between 2 points can be expressed in that form we just wrote. So y equals y1 plus m times x minus x1. Now we will use, if you take calculus, we will use that so many times. You're going to be grateful that you kind of learned how to do it this year. So which one of those variables is the slope? Yes. And then how can you represent a point on the line as an ordered pair using those variables? Like I said that really weird. What do you think represents a point on the line? X1, Y1. Good. All right, and then we're going to use something that we practice a lot in here. We're going to use the average rate of change formula. To find the slope, or that same formula I started with at the beginning. The slope formula, average rate of change formula is the same formula. All right, so let's start with example 1. Example 1 is about as straightforward as it gets. We have the 2 points, the x1, y1, x2, y2, and we want to find the equation of that line. And so we're going to just start off and find the slope, where we'll just subtract the y's in the numerator and the x's in the denominator. Just keep your order consistent and you'll be fine. All right, so it looks like we're going to get 19/5, which is fine. That's a perfectly acceptable slope. All right, and then we're just going to go back to that formula for the equation of the line. We'll put that in for m, and then you just get to choose if you want to use the first point or the second point for the y1 and the x1. Do you guys have a preference? It doesn't matter. Anyone have a preference? Okay, let's just go with the first one. So y is going to be equal to the y coordinate of that point, which is -5, plus the slope times x minus the x coordinate. And I know in Algebra 1 was the main class you learned about lines. And slope-intercept form was so important. We honestly don't care about slope-intercept form anymore. Just leave it in this form. This form is perfect. Don't worry. We can still use it. It's no big deal. All right, example 2, we have a little more work to do. So this time we have a function, and we want to find the equation of the secant line through the points when x equals -2 and x equals 3. So the first thing we have to do is get to the ordered pairs. So we want to find the y's that go with each of these x's by plugging them in. Now you can use a calculator today if you want to. I think you can plug this in your head though. So when I plug in -2, I'm going to square it, and then I'm going to subtract 5 from it. And what is that going to give me? -1. So it's 4 minus 5 is -1. All right, and then I will plug in 3. So when I plug it in, I'm going to square it, and then I'm going to subtract 5 from it. 4. All right. I feel like that's probably good enough for your work, especially on a calculator question. If you want to, if it's just going to help you, you can write these as ordered pairs. That's strictly for your benefit. You don't have to do that for me. But sometimes it helps people like kind of figure out which is x and which is y when you write it as an ordered pair. All right, and now we're going to do the same thing we just did on the first problem. So we'll go ahead and find the slope between these points. You guys do that on your own, please. Now the good thing about quadratic functions and any polynomial function is unless there's some kind of fraction or decimal involved in the problem, when you do the average rate of change, you're going to get an integer. So you'll get things like 1 or -3 or whatever. So that's kind of handy to work with. All right, and so now I'm going to have you guys use the slope and whatever point you want to and write the equation of the secant line, please. I'm going to write both of them. You don't have to. And this one, these ones right here, you don't actually have to write if you don't want to. So you can leave out. If that slope is 1, you don't have to write it. I just wanted to write it just till you get really comfortable with this. All right, and you only have to write one of these. So when you go to check your answers, I'm going to write both just so you can make sure you're right, but you only have to have one equation. They're both perfect. All right, so what questions do you guys have so far? Does it feel weird? Can you get the slope? Okay, so it's just the average rate of change. You're subtracting the y's in the numerator. If it's minus the negative, you do plus. And the x's in the denominator. All right, and then after you get that, you're just going to pick a point, put the x here and the y here of that point, and then the slope. Yes?
Do we have to write the 1 in front of the...
You do not have to write the 1 if the slope is 1. All right, any other questions? So now we're going to do some contextual problems with average rate of change. But what we just did is the main new thing that we're learning today, plus we're also going to interpret the meaning of the slope. All right, so last year on the AP exam, this is very, very much like the question that was on there. It is like, it's public knowledge. I could use the exact question if I wanted to, but I changed it just a little bit and I left out some parts. But on the initial day of sales, which is when t equals 0 for a video game, there were 20,000 units of the game sold that day. 51 days later, there were 56,000 units of the game sold that day. So A wants us to use the given data to find the average rate of change of the number of units of the game sold from t equals 0 to t equals 51 days. We're going to express our answer as a decimal approximation. If you don't do that, you don't get the point. And we're going to show the computations that lead to the answer. If you don't do that, you don't get the point. So you make sure that you read everything it tells you to do. Okay, so we are going to start off, and I'm just going to write an ordered pair for each bit of information that they gave us. And so the first coordinate is always the independent variable, and the second is the dependent. So do you think days is going to be independent, or do you think number of games sold is going to be independent? Days has to be independent. All right, so what's the first independent variable? 0. And then what goes with it? 20. You can do 20,000 if you want to. I'm just going to do 20, and we'll take care of the thousands later. All right, and then the other one is day 51. 56,000. Okay, and so what we're going to do is find the average rate of change between those 2 points. So what are we going to subtract in the numerator? 56 minus 20, and denominator is the 51 minus 0. Okay, so on this question, you have to have a quotient. This is a perfect quotient. If you do 36 over 51, that is also a perfect quotient. If you do 56 minus 20 over 51, that is also a perfect quotient. But if you don't have a quotient, a little fraction that has something on the numerator and denominator, you don't get credit. All right, so type this in the calculator, please. Bless you. So I think the majority of you typed it in like a little fraction. That is the best way to type it in. But again, if you give this answer, it's 100% wrong, which is frustrating because it is a right answer, but they want a decimal approximation. So you can either take 12 and divide it by 17, or you can hit math and then choose number 2 and change it to a decimal. But this is going to be the answer we need to give. All right, and you're going to hear me say this a lot, so hopefully eventually it's going to be in your brain. You have to be accurate to 3 decimal places. So if you say 0.7, nothing. If you say 0.71, nothing. So you can either go past 3 decimal places, or you can truncate after 3, which is just drop off after the 3 decimal places, or you can round. So there are multiple correct answers. But what people do, they just look at the first 3. So you can write all of them if you want to. I'm going to round. Whoa, there we go. And because I'm a calculus teacher, I'm also going to write the units on this. You don't have to in pre-calculus, but we're going to practice it just because it is good to think about. So, what did I subtract in the numerator? Like, what is the 56 and the 20? Number of games sold. Almost. there was more than 20 games sold. How many were sold?
Thousands.
Thousands. So we're going to say 1,000. We're going to spell it right, though. You can say, I'm going to say units because I said that a lot. And then what did I subtract in the denominator?
Days.
Days. Good job. So I think writing that kind of helps you on the next question to talk about like what this really means. So what does the average rate of change over that interval really mean for the situation about the games? What time frame are we talking about here?
Like days.
Between what 2 days?
Just 0.
Good. So between t equals 0 and t equals 51 days. What is changing in this average rate of change?
Games sold.
Number of games sold. So we're going to say, you can say games if you want to. I'm just going to go ahead and say units. Right. Would you say that the number of units is increasing or decreasing?
Increase.
Why is it increasing? You're right.
It's going up.
Because it's going up, but why is it going up and not going down?
It's not a negative.
Good, it's not a negative. So positive means increasing. So the number of games sold increased by 0.706 thousand. Why do I want to spell thousand? Units each day. Or you could say per day, it doesn't matter. Right. And then on C, we're going to use that average rate of change we found back there at A. I put I, but it technically should be A. To estimate the number of units sold on day 30. And we're going to show the work that leads to the answer. So this is another one. No work means you're not going to get it. And so what I would do is I would write a secant equation, since that's what we're practicing today. All right, and then we get to choose the points. Which point do you think would be easiest to use? The one that has 0. All right, Davis, here we go. Here's our secant line. We're going to use this point. What number are we going to write after the equal sign? This is our formula. 20, yep. So it's going to be 20. And then we're going to do plus. All right, Sadie, what are we going to put in for M?
0.796.
Good. And then X is just regular old X. And then Peyton, what are we going to put in for X2? I mean X1, sorry. 0. It's okay if you don't write that 0. I'm just writing it because this is the first day we're talking about this formula. All right, and then to answer this question, what are we going to put in for X? 30. Now you probably haven't seen like Y of 30. That's perfectly fine. That's not something that you write that often, but when I plug in something in for Y, I go ahead and I write it as Y of 30. Okay. And then you would just type that in the calculator, and you would want to be accurate to 3 decimal places, but I'm pretty sure it stops at 2. So we would just go ahead and write the whole number. Is that how many units are sold that day?
1,000.
That's not many. 1,000, yeah. All right, how you guys feeling? Good? All right, so I like to hear. All right, on the back, those same questions are going to be plus 2 that we've already done before that we haven't practiced a ton. And on our test next week, there will be a free response question very much like this, maybe with a couple more parts added to it. But definitely everything on here is going to be on there. All right, so this equation, a ball is launched from the top of an Empire State Building. Heights in feet at given times in seconds of the domain are shown in the table below. All right, so A1 says to use the table of values to determine if h is best modeled by a linear, quadratic function, or neither. So how do you do that? The first and second differences, right? All right, so let's find those first and second differences. So take one, subtract the previous one, please. All right, so this is definitely not linear, and you probably already knew that because you know that objects don't fall at the same rate because of gravity. So we're not linear, so let's subtract again and see if this is quadratic. All right, so after you get that, see if you can answer the next two questions and see if you can word it, see if you remember the wording. If you don't, it's okay. You only practice it like one day. So just make sure you did mention input and output. And those input intervals it's very specific what they're like. It is probably okay if you didn't include this negative 128. It's best if you do, but you would still get the credit if you didn't give the value. All right, so now we're gonna add the new stuff to the old stuff. And on B1, we are going to use the given data to find the average rate of change of the height of the ball from t equals 0 to t equals 6 seconds. So even though there's a ton of other points in the table, the only points we're going to use are the ones with 0 and 6. So just these two. All right, so we'll subtract the y's in the numerator and the x's in the denominator. Right, and since this was a nice, pretty quadratic equation, and we didn't use any fractions or decimals, we get a nice integer average rate of change. What should my units be on my average rate of change?
Feet per second.
Thank you, good. All right, so now we're going to interpret the meaning. So I like to start with the time frame. So my time frame this time was between t equals 0 and t equals 6 seconds. What is it that's changing in this problem? Height of the ball. Is that height increasing or decreasing? Decreasing. Now we're not going to say it decreased by negative. When something decreases by negative, it actually increases. So we're just going to say decreased by 71 feet each second. All right, any questions on that? Okay, and then the last thing we're going to do is we're going to use that average rate of change that we found to estimate the height of the ball at time t equals 3. So again, I would start off with a secant line. You can only use the points we use for the average rate of change. So even though we know all these others, they're not going to give you the right answer. So you get to choose between those two. All right, and then this time we're going to put in 3. All right, what do you guys think? Does anyone get it? No? What'd you get? Thank you. I think you said that.
Oh, I did my points.
Okay.
Apologies, guys.
That's okay. That happens to best of us. I messed this all up last period, so yes.
Why do you just pick between the 1.54 and the 1.3?
Okay, so you have, when you do your equation, it has to be one of the points that you used to do B part. So you can get an equation, it just won't be an accurate equation on the other points. All right, anybody else have a question?